We are in sequences and series. Don't mind this. I had to white it out because I made a video and there's a few errors. So let's talk about sequences. We have a recursive formula. We're starting out with -6 and we add 4 every time. We want to find the 10th term. So if I want to find the 10th term of the sequence, I need to take the term before it and add 4, which is term 9. I don't have term 9. I'd need term 8 for term 9. And to find term 8, I need term 7. And to find term 7, I would need term 6. So that means we have to start at the beginning and say, okay, this is my first term. To find the second term, I'm going to add 4. Then I'm going to add 4 again. Then I'm going to add 4 again. And again. Okay, and my goal is to find term 10. So term 10 is 30. Okay, so that was a pain. We had to do all that work. Okay, we had to do all that work to figure out what term 10 was. Okay, so in order to find term 10, we had to find every term before it. Wouldn't it be nice just to substitute in a number 10 respective to the term being sought after? So wouldn't it be nice if we could just plug in 10 and get 30? Okay, we can. It's called an explicit formula. If we just have this formula, t sub n for n minus 10, this formula and this formula both represent our pattern, but this one we have to find all the previous terms, and this one we don't. If we just plug in 10, we get 30. Okay, so how do we get it? I said t sub 10 is 30. Maybe it would just work for that term. Does it work for all terms? What about t sub 5? Okay, so if I plug in 5, I get 10. So if I plug in 5, I get 10. Okay, so it does work. How do we derive the formula? Well, when you simplify, you're no longer seeing the pattern. So the pattern before was -6. To find the next term, we took -6 and we added 4. To find the next term, we take that -6 plus 4 and we add another 4. To find the next term, we take the previous term, which is 6 plus 4 plus 4 plus another 4 now. So we notice a pattern. We're always going to start with -6 and we're going to always add 4. How many 4s? Well, if my n is 3, let's say, I'm adding 1 less. I'm adding 2. If my n was 4, I'm adding 1 less, 3. So I'm adding 1 less 4, n minus 1 times. So if I want to find the 10th term, I'm taking -6 plus 4, and you start out with 6 as one of the digits, and you're adding 9 more. So when I'm doing this, I'm in the calculator. So 10 minus 1 is you're adding 9 4s, which is 36, which, yep, you get 30. Okay, so you can write it like this, or you can simplify it, write 4n minus 4 minus 6, which is 4n minus 10. Okay. Okay. Here, we would just say whatever term you're trying to find, you take the first term and you add it to your common difference n minus 1 times. You don't need to start out with the second term. Okay, you don't need to tell the reader what the first term is. You just have to replace it in there. So for example, it says write an explicit formula for the term of the sequence and then find this indicated term. So here, whatever term you're trying to find, you start out with your first term and you're going to add what looks like 4 every time n minus 1 times. So this is your formula, or this is your formula. So to find your 12th term, you take 11 and you're going to add 4, 12 minus 1, or 11 times. Okay, you should get 55. So in a calculator, if I did 11 plus 4 plus 4 plus 4 plus 4 11 times, the 12th term should be 55. Okay. Here, same thing again. I'm starting out with 14. Okay, you might want to pause and try these on your own. I'm starting out with 14 and I'm adding, well, actually adding a negative number. I'm adding a negative 5 and minus 1 times. You can leave it like this. That's fine. Or you can simplify and say, okay, my formula is negative 5n plus 19. So then when I try to find the 12th term, I simply substitute in 5, and what do I get? So negative 60 plus 19, you get a negative 41. Okay, we're going to do the same thing again with the last one. We're starting out with a negative 80. We're actually adding 4 and minus 1 times. So you can leave it like that, or you can simplify and say 4n. Why did I do that? Oh, I tried to do it all in my head at once. 4n minus 4 minus 80, so minus 84. And when you're trying to find the 12th term, you get 48 minus 84, which is 36 negative. Okay? All right. Now, what if it was geometric? It's going to be the same thing. If you're trying to find the 10th term, you need to take the 9th term times 4. So what you would need to have done was go back to the beginning. Well, we could have done it like this. The first term is 3. The second term is 3 times 4, which is 12. But leave it like that so you can see the pattern. So the next term would be that 3 times 4 times another 4. If you're trying to find the 4th term, it's the previous times another 4. So it's whatever term you're trying to find, it's 3 times 4 to the 1 less than what you're finding. Okay, so if I'm trying to find the 10th term, I take 3 and multiply 9 fours. Okay. Is 7, 8, 6, 4, 3, 2. Okay. All right. So it said, how do we derive the formula? Well, we just did it. We already did it. So what it would be is whatever term you're finding, it's your first term times r to the n minus 1. You're writing in what t sub 1 is. You don't have to start from the second term. So we're going to do the same thing again, but with geometric. It says, write an explicit formula for the nth term of the arithmetic sequences. Find the indicated term. So the formula is our first term times what you're multiplying by each time to the n minus 1. There's the formula. Comma, then find the 12th term. So you're starting with 1, you're timesing 3 to the 12 minus 1. So you're going to take 1 and multiply by 3 11 times. You're going to get 177,147. The next one, same thing here. You are starting with 1, you're multiplying by a third to the n minus 1. Okay, if you don't write 1, it is what it is. So to find the 9th term, you're taking 1, multiplying by a third, 9 minus 1. Here's the thing. If you put 1/3 to the 8th in the calculator, you're going to get something a little gnarly there, right? So you know here that 1 to the 8th is 1. So just do 3 to the 8th, 6561. Okay, or you do math, fraction, enter, and I'll give you a fraction. Either way. Okay, here you start out with the square root of 3. You're obviously multiplying by a square root of 3 every time to the n minus 1. So if I want the 15th one, it's square root of 3 times square root of 3 to the 15 minus 1, which is 14. Okay, if I do this, if I do square root of 3 times square root of 3, oopsies, I get this. I don't want a decimal rounded. So here's the thing. It's because it's to the 15th power in a sense. When it's to an even power, the square roots disappear because a radical times a radical is a whole number. So square root of 3 times, well, what's square root of 3? To the 14th. 2187. So switch it around. Okay. All right. So I want you to try the ones on the back. I want you to pause the video and then check. All right. It tells you a sub 1, same thing as t sub 1. Just depends on the textbook you use. So they're giving you your first term. They're saying you're adding 9 every time, and they want you to find the 11th term. So I'm trying to find the 11th term. I know it's the first term plus 9 and minus 1 times. But they also want you to put 11 in here. So that means we're going to add 9 10 times. So it's going to be 104. 104. All right, they want you to find the 18th term. Your first term is 12. What's happening every time? You're adding 13. 18 minus 1 times. So 18 minus 1 times 13 plus 12 in the calculator. They want you to find the indicated term. The indicated term is 7, whatever your nth term is. So I'm finding the 7th term. You can say a sub n or t sub n. I'm trying to find the 7th term. I know it's the first term. Oh, we're multiplying 3 to the n minus 1. So it's negative 2/9, 3 to the 7 minus 1 to the 6th power. So 3 to the 6 times negative 2 divided by 9. Negative 162. Write an equation for the nth term of the sequence. I am trying to find not the 5th term. I'm trying to write an equation now. I want a sub n, a sub 1, plus a common difference n minus 1 times. So what can I replace? Well, it's always going to be a sub n. Your first term you need, your common difference you need, which we have. So all I need to know is the first term. Well, if I am at negative 12, I need to find the first term, okay? Well, I know the 5th term, okay, is negative 12. I don't know the first term. I know the common difference is negative 4. I'm going to put a 5 in here because I have the 5th term. So the 5th term is 12. I'm going to put in a 4. But add 16 to the other side, it's 4. So my formula is a sub n, 4 plus your common difference and minus 1 times. You can leave it like that or simplify. Here, they're telling you the first term is 13. You know your common difference is, well, here it's 6 and minus 1 times. You can leave it like that, but a textbook might give you 6n plus 7. They want you to write an equation. Always refer back to the directions. What do they want me to do? They want me to write an equation for the nth term, meaning whatever term you're trying to find. Well, it's an r, so we're not adding this time. We're going to multiply by r. What can I replace? I need to replace a sub 1. I need to replace r, and I need to put that there, and then that's it. So I know I have a sub 2, which is 4. I don't know my a sub 1. I know my common difference is 3. Or I'm sorry, my common ratio. My n is 2 here. So knowing everything I know, can I figure out what my a sub 1 is? Absolutely. 4/3. So my equation is a sub n equals 4/3, 3 to the n minus 1. Okay. So if you're trying to find something, write an equation, fill in everything you have, and then the last variable that's there, that's what you're solving for, and then you write your equation. And that's it. So your homework is page 670, multiples of 3, 15 through 30, and 678, 18 through 33, multiples of 3.